Suppose secant of theta is equal to 4. Find all the other trig ratios from 0 to 180 degrees. And to the nearest degree, determine possible values in the domain from negative 360 to 360. So we'll look at part A first. You want to find all the other trig ratios. So we want sine of theta, cos of theta, and tan of theta. Those are our primary trig ratios. And we want to also have cosecant of theta, secant of theta, and tan of theta. Those are all the 6. And they tell us already secant of theta is equal to 4. So there's one that we can find right away. Of all those 6, there's one that is the easiest to find right away. Cos. If secant of theta is 4, cos of theta is 1 over 4. And now, since we're dealing with trigonometry, there is a very important strategy to use. Draw a triangle. And we have enough information to draw this triangle very accurately. First of all, I'll just draw my axes over here. I know what quadrant I have to draw my triangle in. Right? We always draw a triangle with a reference angle. What quadrant is the triangle going to be in? Quadrant 1. Why? Well, first of all, they said between 0 and 180. So then you were between quadrant 1 and quadrant 2, and that was a 50-50. You might have just guessed. That works half of the time. But we know it's in quadrant 1 because cos is positive. If cos is positive, according to our cast rule, it has to be in quadrant 1 or quadrant 4. But because they said just look from 0 to 180 degrees, we know that it's in quadrant 1. When I draw it in quadrant 1, labeling my reference angle, which in quadrant 1 happens to be identical to my angle, right? In standard position, here's my angle theta. Can you see that it's identical to my reference angle when it's in quadrant 1? And we know that cos of theta is 1 over 4, and cos is the adjacent over the hypotenuse. So if we draw a triangle where the adjacent divided by the hypotenuse is equal to 1 over 4, we're going to be fine. Now most people use actually 1 and 4. You could have used 2 and 8, because 2 divided by 8 is the same as 1 over 4. But for the most part, when we draw this, we're going to say, I know cos is the adjacent over hypotenuse. I'll label the adjacent as 1. My hypotenuse is 4. You're going to get really good at a squared plus b squared equals c squared. Do the mental math in your head. Okay, that's enough time. Did you get 15? Why isn't it 17 this time? Because 4 is the hypotenuse. Right? A squared plus b squared equals c squared. We'd have 1 squared plus b squared equals 16. You'd move your 1 over to the other side. B squared would be the square root of 15. Or b squared would be 15. And b would be square root of 15. And now that you've drawn your triangle, what sign? Opposite over hypotenuse. Done. Quadrant 1, positive. Done. What's tan? Opposite over adjacent. Quadrant 1, positive. Go to the other ones. Now it's reciprocal functions. Cosecant, reciprocal of sine. 4 over root 15. Oops, I wrote tangent twice. Cotangent, reciprocal of tangent. 1 over root 15. Good. To the nearest degree, find possible values of the angle theta. And now we're going from negative 360 to 360. So what happens in part B is we're going to steal our triangle from part A. It still is true. But in part A, this was the only information that was given to us. This is the only thing that we started with. Secant of theta was 4. We know cos of theta is 1 over 4. We drew it in quadrant 1 in part A because it said from 0 to 180. But if we went from 0 to 360, according to our cast rule, can you see that there was also the possibility that your reference angle could have been in quadrant 4? Because cos is also positive in quadrant 4. You would still have 1 here, 4 here, and square root of 15 there. But that would be a different angle in quadrant 4. But cos of theta would still be 1 over 4, and secant of theta would still be 4. So to solve for theta, we're always going to find our reference angle first, because our reference angle is going to help us figure everything else out. When solving for a reference angle, you're using the actual triangle and you are using all of the values as positive. Doesn't matter, right? Because here in quadrant 4, tan of theta would be negative. But if you're finding your reference angle, you always use positive values all the way through. Now I'm going to use cos of theta is 1 over 4. Are you okay if I say cos of my reference angle is still 1 over 4? Because in that triangle, either one, cos of my reference angle is 1 over 4. Going to have to go back to grade 10. How do we use our calculator to find an angle? What would you type in? The inverse. Okay? Now, I don't know what it is as math teachers, but we don't do this. Okay? And maybe your teacher did, but we often don't do this. How do I get rid of a cos? I cos inverse both sides. Did your math teacher ever write cos inverse on both sides and then write, but for whatever reason as math teachers, we just go right to this next step. Do cos inverse. But what cos inverse is just like any other inverse. If you had plus 4 on both sides or plus 4 on one side, wanted to move it over, what do you write? Minus 4, minus 4. You inverse it to move it to the other side. If you want to get rid of an x squared, what does your teacher tell you to do to both sides? Square root both sides. For whatever reason with sine, cos, and tan, we as math teachers often don't say, oh, cos inverse both sides. Cos inverse and cos are inverses. They cancel each other out. You just get your reference angle. And then we go to our calculator, and now we have cos inverse of 1 divided by 4. And our reference angle is 75.5 degrees. Does it say to the nearest degree? To the nearest degree. So 75.5 to the nearest degree, our reference angle is 76 degrees. Now that we have our reference angle, we can find our actual angle. Remember the domain for this one? I'll just write it down here. We want to look between negative 360 and 360. Mentally, when I'm thinking about a domain like this, I look at positive angles. They start at 0 and go to positive 360, and negative angles separate. Where are our angles? we have one in quadrant 1 and one in quadrant 4. So if I was going in the positive direction, I would hit one here and one there. Those two positive angles, one of them would be identical to my reference angle in quadrant 1. And my one in quadrant 4, can you see that you could do 360 degrees minus your reference angle? Which would leave you with 284 degrees. Those would be my two positive angles. After I do my two positive angles, I would then think about my two negative angles. Again, standard position starting at 0. I'll do negative in red. You would have this one here, and you would also have this one here. Mathematically, I deal with my negative angles the same way I think about my positive angles. This first negative angle, it's the same as my reference angle, isn't it? So I'm going to write negative 76 degrees. And this angle in quadrant 1, when you're going in the negative direction, quadrant 1 is like going to the fourth negative quadrant. How do we do an angle in quadrant 4? Well, I would have done 360 minus my reference angle. So I'm going to do that again. 360 minus my reference angle is 284, but since I'm going in the negative direction, I'll get negative 284 degrees. And questions to practice on this one are 9, 10, and 11.